Today's lecture is about iterators, generators, and special kind of symbols. I welcome you to another lecture of Rolling Scope School, Poland 2020. And me, Dmitry Belichuk, is your today's lecturer. I'm a full stack developer. I usually work with React, Node.js in production, and generally like to play around with anything JS related in non-production. I give lots of lectures, and I also mentor people in different JS related technologies. If you have any questions after the lecture, you can contact me either in LinkedIn or directly here in Teams, or you can look around in through my repositories on GitHub. So today's agenda is we'll first look at the iterator principle. What is an iterator, and how does this principle what does this principle have to do with functions that you previously had a lecture on? Then we switch to symbols, because symbols are essentially the thing in the JavaScript language that help us to build the next topic of our discussion, which is iterable. After that, before we switch to generators, as one of the iterators cases, we need to discuss the run to completion principle. How does the run to completion principle is sort of violated when it comes to generators. We will look at more examples of generators briefly, because at this point it's a very hard topic to grasp in one lecture. But these examples are generally made for you to be able to reuse the code and build on top of that. So, what about the iterators? Remember, in the previous lecture, you discussed the functions as the way to encapsulate some kind of a logic inside a block, and then reuse this logic, calling it again and again and again. You also learned that the functions are like primarily different type of thing in JavaScript language compared to data types, which are collections of different kinds of data. So we have arrays, which are collections of any type of data in ordered list. Then we have an object, like a more general thing that can contain key value pairs. We also have something called like linked lists, or doubly linked list, or stacks, or hashes, all these kind of data types. And in general, when we want to look into those data types, into those, I should say, containers of data, we have two choices actually. We can manually retrieve some values. For example, in arrays we use an index, or in an object we use a key and we get the value back. Or we can do this automatically by iterating through the data, looking for the stuff we need, and actually getting something out in the end. Remember, you use the for loop, or maybe something like for each or map as methods of array. How do this like built-in functionalities go through the data? And this brings us to the topic of today's discussion, which is an iterator. So basically, you can think of all these looping built-in functions as using the iterators, which is an object that enables a user to traverse any kind of list or containers. It also is a design pattern because, as I mentioned, like when we have some kind of data container and we need to go through that data container either one by one each time we have next element or skipping some of them, we implement something called an iterator, which is an approach of defining the way we go through something. You can see in the picture we have a Rome or some close depiction of Rome. In the center we have the Colosseum, and the Rome is a big city, and we imagine the Rome being that list or that container of data, and we want to find the Colosseum. How do we get there? We have several choices depicted on the three next pictures. We have either like an option to wander around asking people about the way and eventually getting there, like spending lots of time. Imagine like an analogy in programming, which is iterating over a list and just taking one element at a time, one by one, and slowly getting there. Or we can use something called a GPS navigator and actually look for some patterns or something helpful that can retrieve the exact location and help us to go to the Colosseum. And the third option, the most expensive one, is we can take a tour and like someone could take us. A tour guide is something like a hash table in the programming languages because it remembers where the key is located in this container and immediately retrieves the value. So you have this kind of analogy. So when it comes to JavaScript language, how do you actually go around this principle of iterator? You basically think of the iterator as an interface, like an object with an interface that lets you step through a session of series of values. This interface describes that the next function, when called, is producing a value from the collection that we're iterating through. When we produce all the values, when you retrieve all the values from the iterator, it means that the iterator is consumed. So basically left with no data left, and we reach the goal. And in terms of the language, it means that even if we call the next method, we simply should get some kind of notification about that we're done. There's nothing to iterate through. So bringing this definition of iterators, we can kind of guess that we can have an object with a next method that retrieves some kind of value, and then when no values are left, it returns just something like done equals true, which notifies the user of the iterator that it's now has ended. So this is how it looks, like a big example of the iterators. So on the left, we have a depiction of a small program, and it just means that we have a something, which is a variable, where we store a object. So you can see we have immediately invoked functional expression, which is there just so we can have this next val variable remembered throughout all the next calls. And then immediately in the something variable, we get the object. And this object contains a very strange thing, which we'll review next. And then this next method, which is a function that returns some values or does something with the value. And then when there's no values left, it just returns something. So done is false and returns value next. And this is how we consume this iterator. So let me just briefly skip to the comments. There's no comments so far, so that's okay. So by looking at the code, we can see that the next calls actually never end. This is a very good notion because, as I mentioned previously, that the iterator is complete when we get done equals true in the end. So this might be a problem, but actually, if you think about it, iterator is something that could be used as infinite producer of values. So it's like a function that you call and it returns some kind of either random or a very specific data, and it does that infinitely, some kind of like almost like producing values, all the new values all the time. And in JavaScript, for this, it's kind of like for this manual retrieval of values, something .next.value, we have a very convenient syntax, which is enabled by having this line of code in the Iterator object. This line of code is used for a special kind of for loop. It calls a for of loop. And that brings, the whole thing brings us to a special symbol thing in the JavaScript language that was added specifically to hold the constants in the language. And one of the constants it holds is an iterator. So whenever we want to actually go through an iterator like automatically without actually manually calling next function again and again, we use a for of loop, this one on the left. We provide an iterator to it, and what for of loop does is it looks inside the iterator and looks for this thing. If it finds this thing, it can safely loop through the iterator automatically, and as you can see, we actually having a break statement that ends the iteration. So we no longer need to check if done is equal true, but we're actually just checking the value and breaking a for of loop. So the key takeaway with the symbol is that with a special syntax called a dynamic object computed property in the object, we have a way of defining a special iterator property that for of loop looks inside an iterator. Why do we need this? As I mentioned, we either do something manually or we do this automatically. This is a way for the JavaScript developers to do something automatically with the iterators. This is something close to the building functions, for example, for each or map or any kind of loop that go through data and retrieve something. They have something like symbol iterator defined inside, and when you try to loop through them, that building thing actually retrieves the iterator back. So that brings us to the iterable objects. We have this confusing situation here. We actually have an iterable object and something called iterator. The more easy way, more easy way to think about the whole thing is that when you want to define your special kind of iterator, for example, an object through which you can iterate, you actually need to create an iterable object so that inside the iterable object, you will have an iterator. So we have special things like arrays, strings, etc., that have this map, reduce, for each methods that can iterate through arrays. But for example, for objects, we don't have such functionality. And if we want to use the similar syntax for objects, we need to provide an iterator. So iterable object is an object that contains an iterator. And an iterator you can think about as object that knows how to traverse, how to go through an iterable object. So you can think about it like a Venn diagram where the iterable object is the big circle and iterator is a smaller circle inside that bigger circle. So again, with the previous example, we have var something that is actually an iterator, and it has next methods on it interface. So the next methods and the simple iterator computed property in the return object is an actual iterator interface. When I mention iterator interface, this is a very general way to say that the iterator itself inside the JavaScript language is actually a very just a documented thing. Some of the JavaScript creators, they one day just decided that iterator should have this next call like all the other languages. They just wrote it down, named it like an iterator protocol, posted it on some kind of JavaScript documentation page. And so from now on, we as JavaScript developers need to follow that protocol. This is what the next and the simple iterator thing is all about. In that protocol, iterator protocol, you have a symbol, which is used for for loops, and the next method, which is a method that helps us to iterate. So, and then they decided to provide a description, like documentation for the thing called Iterable Object. And at that protocol, Iterable protocol, they defined that this is an object inside of which we have an iterator, and the way to retrieve that iterator is actually using the same thing that for loop uses, which is using the simple iterator. So again, when we have a variable, which is an array of numbers, and we have a for loop, we know that we can use this for loop on the array because arrays are built in such a way that they have an iterator already, unlike the objects. So as an iterable object, array can be traversed not just by using a for loop or any other map reduce for each iterators, but also by manually getting that iterator and calling the next dot value on it. So as you can see, A is an array. We have a for loop iterating through it, and we almost the same way as automatically iterating through it, have a way to manually iterate through it by retrieving that simple iterator. So just look at the syntax. We're getting some property on an A object. This is almost the way that this array is something like this object that contains this iterator, and then inside somewhere there's a data that actually contains inside of the iterator, an array. So we have an iterable object, which is an array, for example, and we retrieve some value from it by getting the iterator using the symbol iterator. So in the end, JavaScript creators, I should say, they decided that the language needs some kind of built-in tools to depict the iterator protocol and an iterable object. So they decided that the array as an iterable object should have something like map, reduce, for each functions that help us JavaScript developers to use it. But for a more general construct, such as simple JavaScript object, they couldn't decide actually how to like define an iterator, because objects are things that are more general than an arrays. Arrays are ordered lists of something, and they have all these useful methods. But an object is a more generic thing. We are, as JavaScript developers, are responsible to actually define that iterator on objects. So, and we do this similarly as I did here. So we define something called like simple iterator property inside as a function that returns this, which is this object. And since this is the object itself, we have a next function call, a method that does the work. So if I want to have a special kind of iterator for my own object, and it needs to do something special with all the keys, not just retrieving one key at a time, I define an iterator. That's how it's used. So basically, a key takeaway from the lecture today, I think, would be that there is a way to define your own for of loop-ish thing inside the language for your own iterable objects, meaning your objects, with all your data. But that's not all what the JavaScript creators did in the past. Remember from the previous lecture, we had this discussion of that the functions are actually a blocks of code, or a way for us as JavaScript developers to create blocks of code that get the values, or I should say, that do some work for us. And there is no way that we would have this function thing without actually being sure that the function will finish what it's supposed to do. So functions are just a way for us to define some number of tasks and making sure that are like evaluated one at a time. And this simple concept is actually a very general concept in computer science field, and this concept is called run to completion principle. And what it means that we are, as JavaScript developers or any other language developers, we're basically not even thinking about that line number 1 will be interrupted by line number 2 or line number 3 or anything like this. We know that after 1 goes 2 and then 3, and when it's done, if it's a function, we only then proceed to the next thing in our program. So what I mean by this is that whenever a function runs, it cannot be like interrupted, and the function will run forever if it's not interrupted by any other thing. And this notion of running forever is actually quite a bad thing if a function cannot finish. Our application just freezes. You have this memory leaks, or you have an infinite loop thing in the front-end development when your browser just freezes and you cannot see any changes on the page because JavaScript engine is running infinitely some kind of task. So this principle is a help. It simplifies our way of thinking about the program, and it's also a limitation. We cannot go like bypass this limitation. We know that if we define top to bottom our program, it just runs top to bottom. Nothing will change that. Functions are a way for us to rip parts of the code and by calling them, decide when some kind of program is executed. But it still runs the way we define the program. So it's a general principle that it's at least in JavaScript language could not be bypassed by any means of multi-threading or like using different processes for actually like doing a parallel work. So as an example, I will show you a small program which reads like this. We have an x variable that equals 1. We need this x variable being defined using var keyword because we want to access this variable like anywhere in our program, and we want to actually redefine it to a different value. So here we have a full call at the bottom, which itself does 3 things. It increases the value of x stored in x to a 2. Then it calls bar function, and then it actually calls a console log. And we expect to see a 2 or 3, which is actually a question. But by the way of this run to completion principle, we know that before doing a console log, we go inside bar function, we execute it to the end, and then go back to the line where we called bar function, and then proceed to console logging. So by this principle, we see on the screen that x is equal 3. So by taking out the bar function, by taking out the call to the bar function that changes x the 3rd time, or I should say like the 1st time, if we count just the x plus plus, we make sure that the console log gives us 2. But what would be the way for us to somehow interrupt or get between the function called console log and x plus plus without actually executing bar function and actually like calling this run to completion principle? This is where we come across the generator principle or generator concept inside the JavaScript community. So there are no questions so far. That's okay. So the whole idea behind the generator or generators is to be able not to parallel the execution of some code, but to actually pause pieces of code and then continue with some kind of other logic. And then once we like done with the logic, we can continue with the pause logic. So simply put, the generator is a function that can be paused. So just look at the example. We can pause the full function at some point, go execute the bar function without actually like calling it specifically inside the full function. Then after executing the bar function, we can unpause the full function. And without even knowing that the bar function is executed, the full function changes or I should say, receives the changed X. So, and we do this by a special function thing inside the JavaScript language. It differs from the basic functions by this small asterisk between the function keyword and the function name. And this special generator function, it does this magic work of pausing and then continuing doing something. Well, the thing that I mentioned earlier in the lecture, it just uses the iterator. So when I call this special full function, which is a generator, it returns the same thing that we used before, an iterator. And every time I call it.next, as we've seen in previous examples, I retrieve the next value. So you can think that this something is defining a generator. Inside the generator, it returns an iterator. And the iterator is actually retrieving some values from an iterable object somewhere inside the generator. So this whole thing about the iterators, iterable objects, and the generators are nicely summarized by JavaScript creators when they introduced this generator concept inside the language. Because now, without even the need of describing how the iterator function works, how and where we store the data in some kind of object, without this whole object notation, we have a very nice way of defining special ways or special functions that work almost as if we executing a simple function, but with a small catch, and this catch is yield. So without this yield keyword, this function something will be just a small function, just a typical function, and calling it.next once we retrieve the value or we execute the whole function, and that's it. We don't get any other way of calling the it.next and retrieving another function. Why? Because there's no yield. So summarizing the whole thing that I said about iterators, iterator objects, and generators, when we define a generator, you need to decide when you want to stop the execution of a function. For example, as in the previous slide, we have this bar place inside a full function. So this is the place we want to stop. That's when we use the yield keyword. And the yield keyword, it almost like it says to the outside world, the world that called the full function, the function that wants to be paused. it says, hey, this is the value I produced. When you want to proceed with the generation of new values, just call it.next, and I will continue from the same spot after yield. So, as I said already, this is a manual traversal of iterable objects or some kind of collections. This new concept of generators, it helps us to automatically traverse something with the same syntax we mentioned before with a for of loop, but instead of passing the whole function by its name, we pass an iterator, as I mentioned already, by calling this generator functions. And it does the same thing. Compare this example to the example that we saw just a couple of slides before. We have this something that is called, and then it returns something in its place. And then we iterate through that thing and have this stopping or breaking condition. Same thing that we did, for example, using the iterable objects or iterators previously. So this is the way to automatically traverse some collection of data or iterable object. So you can think about the ways you can use it. There are very creative ways and very useful ways you can use this newly available functionality, which is, again, I mentioned, generators is a way to pause an execution of some like lines of code under this special function thing. So you can think that maybe when I use some kind of asynchronous code, when I want to retrieve some values from the backend or any other place, previously we had to define a callbacks for that, like saying, once you're done, please call this piece of code that I give you. What if we could do this without actually relying on this other third party? We have these generator things that await for us, the JavaScript developers, to actually call this .next method when we want to continue. What if we could somehow build around this generator basics and actually proceed only when the asynchronous code, for example, fetch of the backend resources are finished? This is exactly what they did when they created the specification for generators. Imagine we have this full function, and this full function actually calls for some Ajax or fetch or any other thing, and we give this function a callback saying that, hey, Ajax, do this function add.data, and once you complete it with the resources, and if there is an error, throw an error. If there is no errors, call the e.next. Next, it is an iterator. We defined it here, while it equals main function call, and main function is actually a generator. So we're saying, hey, Ajax, call that function and give us the data back. We pass the data inside the next call, which is a way for us, the outside world, to pass something inside the generator. If you look closely, the main function, the full function on the left, the main function on the right, they're just declarations functions. The thing that runs is var it equals main function call, and then it.next. So how to read this? you can read it like so, or by calling main generator function, we get the iterator back, and we start the iterators. We start the process of iterating through its contents by calling it.next. What is it.next? We see that there is a try-catch block that actually yields back to the world, so to the outside world, the contents of the full function. So now we have the full function call on the left. It does the AJAX request, and once the AJAX request is finished, either with an error or the actual data, it returns that like notification inside the generator, so the inside world, and we're back at the try-catch try-catch block, either with an error or with the data, and we console log it. That's how it's done. But wait a minute, we have Asynchrony inside the JavaScript language, and we saw that we have a callback way of defining the asynchrony. But what if we can somehow use the promise syntax in the same way with the generator? That's easy. In the same way that we defined earlier, we defined two other functions, foo function, which is responsible for actually making the request. This is just some kind of request name, AJAX, anything, which is like fetch or asynchronous in its nature. We define the actual generator almost in the same way as we did before. So as you can see, main, yield, full. And we expect that from calling the full with 11 and 31, we get back the promise. So the request thing returns the promise with the return keyword. So back at the yield statement in the text, we have a promise. And once that promise is done, we actually get either the data or the error. And we define this done thing by defining the then block. We can define it inside the then block or with all the statement, or we can use it in the catch block. Either way you like, it's actually a very useful thing for the way of asynchrony. So as you can see, previously we just used the either yield the generator either to yield some kind of variable or number or any primitive, or we just used it to get something back immediately or asynchronously. So, but can we imagine the situation that we have a generator like function asterisk main, and we yield, instead of a synchronous or asynchronous code, we yield another generator? Why? What if we want to be able to pause when we traverse the data, and then once we get to a more complex data, and again we want to pause that too? This syntax might sound very strange. Why do we want to pause inside already paused generator? But actually, a whole thing called generator delegation, take it with a grain of salt. It's hard to think about from the first glance, but bear with me. Imagine, as in the previous example, we define this main thing that processes the request, one request. But what if we defined a more general generator function that has lots of generator functions inside, each of which waits for its code to complete what's the use case? Lots of consequent API calls. You want to be able to retrieve one data after another, because the first data is needed to make the second call, and the second call returns the data that needs to be actually shown to the user. So you have the necessity of keeping some kind of code consequent, not the parallel. We cannot rely on the request being processed, like the second request for var R3 to be processed after the R2 is finished. There's no way for Asynchrony to work this way. As an exception, the generator. Using the generator, we actually can enforce the program to wait until the first call is complete and store its value in the R2, and then continue with the second request and store the value in R3, and only then to return it. So previously, for example, with a catch block or with the callback function, we provide a function that the Ajax will execute for us when it's finished. Or with the promise syntax, we rely that the then block will be executed, and only after it's done executing, the next then block is executed. Now, we have a way of actually using one line of code, which is like var2 equals yield request, and then another line on the next one, to simulate the synchronous nature of run to completion program. This is how we do the async await, the newly developed syntax that you will have to look for yourself after this lecture. But the core principle, when you look at the newly added async await functionality in the JavaScript language, is based on the generators and the generator delegation. Every time you use async await, you use promises plus generators. So I believe that that's it from my side. Yeah, when we're supposed to use await instead of yield? Actually, no. As I mentioned just a few seconds ago, we are like, imagine that the async await is a syntactic sugar on top of this complex generator delegation thing with promises inside and lots of generators waiting for its yielded values. A much more like easy way is expected for us, like JavaScript developers, to use, and the JavaScript creators, or like those who write the documentation, they actually thought about it and added to the language a more readable way for us to use this kind of synchronous async code, if I can say that. So think about the async await as a syntactic sugar on top of promises plus generators. So any other questions? Come on, guys, it's a very difficult topic. Better ask questions now. Okay, new message. What about symbols? So symbol, as I already described, symbol is a special thing that was added to the language. You can think about the symbol thing as a namespace for different constants in the language. One of the ways to encounter the symbol, or to actually use something using that symbol, is when you write to when you write an iterator. So generally, imagine that there is some hidden parts of the language that you are not supposed to actually touch when you develop. And then at some point in time in the language evolution, the language creators, the language maintainers, they decide to expose some of this syntax, allowing for us to, for example, define object descriptors or define special ways to traverse data. And they do this by providing this symbol dot something for you, so we can actually target those hidden things inside the language. So very hard topic, very high level, like very low level, and at this point, just like remember that when you want to define your own iterator functions for of loop, you use the symbol.iterator computed property inside an object, and that's where you define the iterator. Okay, next question. Is there any reason to use promises or generators instead of async await? I should say that by today's lecture, you can actually see the way that the language evolved. So we first had no way for us to like define the how we want to pause our program. Then at some point, JavaScript creators, they added this to the language, or I should say, exposed this feature inside the language. And we started, as JavaScript developers, we started to play around with it. And we found actually ways to use this newly added or newly exposed feature with asynchronous code. And then once a more like common way to use those generators with the same code actually settled, JavaScript creators added that like you can call it algorithm of using the generators with promises or with callbacks, anything like that, to the language. So it's your question is like asking, is there a point to use like prototype function, like function prototype, instead of classes? Like classes, async await is like a newly added syntax. You can use this and never use anything again, like generators and promises, or you can opt to a more like old syntax. Why you want to do that? For example, backward compatibility. Some of the browsers, like I don't believe that this states like lots of the browsers are not really able to understand the async await. But for example, all libraries that are written in the callback-based approach without promises could not use the async await. So you can opt to using the callbacks and generators, or you can write your own generators, as I showed with the iterators and iterable objects. So short answer, just go for the async await. It's much easier. It's meant to be that easy. Any other questions? So I think if there is no questions, I will briefly summarize what we did in today's lecture, and then we'll be done. So As like according to the agenda, we reviewed the way for us to iterate over some data in a custom way using the special Iterator protocol. We like according to that protocol, we need to use the symbol dot iterator so that we can actually define the way we go through the collection of data. The object that contains the iterator is an iterable object. There are iterable objects inside a language that are already built in, such as arrays or strings. They already have the iterator like defined inside. A simple object, an empty object, they do not have iterators defined. That's why we use symbol of the iterator and we define the iterators itself. There is a thing called run to completion that says we cannot pause the execution or interrupt the execution of the code at any time. And if the code runs forever, we cannot interrupt and we are stuck in the infinite loop. But that's only true when we use simple functions. If we use a special kind of function called generators, they provide a way for us to stop or pause the execution inside those functions and resume once like some kind of data is available, once we would like for them to resume. They work nicely with asynchrony because that's the way we want to not be stuck with some kind of long-lasting operation, which is a synchronous operation. We want to wait, like pause something, and once the asynchronous operation is complete, it signals that it's complete, and then we proceed. There are several ways we use these generators with asynchrony, which is the old-fashioned syntax with a callback when we have a continuation or when we resume the generator inside a callback, or we're using newly added syntax with promises. Promises allow us to have .then or .catch blocks, and that's where we resume the generators. A newly added async await functionality is built on top of that idea of having the generator and the promises work together. You can actually use the generators inside other generators, and this way of yielding other generators is called generator delegation. Is a way of stocking up some kind of data that needs to be called one by one. So yeah, that's it. If there are no questions, I thank you for today's lecture. I hope it was really useful for you. It could be a bit complex compared to the previous lectures, but bear with me if you spend some time working or like playing around with these concepts. You will get it. You will actually understand why it was added to the language and how you can use it to your benefit. Okay, so there's a small question a bit next to the topic: how to search tables faster and more efficiently. What tables? How do you relate this arrays? How to search arrays faster and more efficiently? You mean what is the fastest ways to go around arrays? Is that what's the question? Okay, so as most of the things in the programming programming field, there are several ways to accomplish anything, and those ways differ with the performance and with the way. If if I take up your question and I divide it into two parts, how do I like go around the arrays and faster and more efficiently? It depends. It actually depends. It's not just a quick way for me to answer your question, but the thing is, as someone in the chat mentioned, map filter it is more efficient and faster than reduce. They have different purpose. So it depends on the task you're solving. If you want to just go through the data without actually using that data, just for example, you need to go n number of times, and this n is the length of array, you just use for each. If you use, if you're not a fan of functional programming, you are a fan of, for example, imperative programming, instead of for each, you use for loop. A great way to go around the data without actually getting that data. If you want to have each time you iterate through a specific item in the collection, and you want to have access to that item you're currently on, you can go with map. Again, a functional approach. If your task is not just iterate through data and producing new kind of data, like a new kind of collection, so map is not your choice. You can have a filter function, like filter method for arrays, which is a way for us to produce a new shorter version. So entirely different case. And if you want to produce a not like even shorter version of the collection, or I should say a sum up the collection to a single value, use reduce. So what is the fastest way to, you can actually write your own iterator for the arrays for your specific task, and it will be the fastest solution, because the built-in things inside the language, they provide a common solution, which is not a really great one if you're developing some kind of custom algorithm. So build up the knowledge about the iterators and generators, and then like write your own one, which will be like I believe will be the faster and more efficient. You're welcome. You're welcome. I hope it was helpful. Okay, so I see people leaving the thank you, mate. Thanks. I think it's time for me to go too. People leaving the lecture. So thanks again. The recording will be available on the YouTube channel. Thanks. Bye.